know what this live podcast or what this post scientist really is. So let me explain it to you guys. Basically, it's a podcast. Obviously, it will going to be online on Spotify, but it's a blog website. But due to due to have more viewers or more uh, people to see our vlogs, we have decided to start this podcast, and it will be beneficial for all of you who are into science related fields, because it will be about only research and scientists uh, are happening all over the world, and whatever the news or the journal is out, it will be you will get to see here, and you will easily can get a lot you can have an amazing podcast. i I'm very sure about this. So let's dig into this, and let's get started with our first topic today, which is taking step towards more effective fitness trackers, more physical activities. Well, most of you already know that if there is lot of scope in fitness, and as we are all in homes during covid lockdown, so it will be very more uh, more like a necessary to everyone, and fitness is very necessary. I mean I wanna say this, and due to which these fitness trackers are the sales is going crazy. That's why now there are some researchers and the scientists who uh, who are meeting or tracking their goals, so it will be achieved, and it will be achieved easily, of course, as now. So let's get dive into this, and let's see what's in this article. As the popularity of fitness tracker has increased, so have the opportunity to use such devices to not only track fitness goals but also increase the motivation to meet those goals. Yes, I mean every single time uh, we don't have motivation to do fitness, of course, because it is very time consuming and also hard working. So many of you don't want to go to gym or something like that, but it is a necessary for nowadays, and that's why this motivation is needed. So yes, researcher in the College of Engineering and the College of Health and Human Development at Penn State had have teamed up to use control system engineering tools to tailor motivational messages sent to individual device users. So, as in this, uh, the researcher from the College of Engineering and the College of Health, of course, have teamed up with Human Development in Penn State at Penn State, and now sending those motivational messages to individual device users, which uh, which I think it's a great step towards fitness. So yeah, the result of their study were published today, October 7, in Health Psychology. Well, it's um, today is I think 10th, but now we are covering it. Never mind. Let's get uh, into it. One of the really exciting advantage at last of the one of the really exciting advances of the last 15 years have been the advent of wearable and portable consumer technology that can be used to help promote physical activity, said David Conray, professor of kinesiology and human development and family studies and co-principal investigator on the paper. You can get real-time feedback from these devices and monitor your goals, and you can even push people messages depending on what their goal are and what their behavior is. We know that those messages work well for improving behavior on average, but nobody is average, but and we don't know how to make sure each individual consistently gets the greatest benefit from a limited number of messages. Yes, of course. It is. Congress said that the researcher had tried several strategies including messages that are specific to certain population segments, messages based on recent behavior, for example sending one of two different messages depending on if a user did or did not meet their goal the previous day, and customizing the message by putting in a person name or something they might like. So far, none of these approaches have proven to be consistently effective in improving the message effects. Okay. The new messaging approach developed by Conray and Costantino Legio, co-principal investigator and professor of electrical engineering, applies tools used regularly in control system engineering to behavior science. Okay. Essentially, we are using the same mathematical tool that people in control engineering usually use to model behaviors as differential equation, Legio said. So it's basically on the previous study only. I mean, in a traditional way. So that's good. We are using those models to design feedback controller that took into account the current state of the person and together with the model decide what is the best time to send the message. So yes, yeah, yeah. Conray emphasized that establishing the correct dosing, meaning the type of message and its timing, frequency, and context, is a critical part of this approach. To this approach, great. We are really prioritizing understanding the dosing so that we are only send the right message at the right time and in the right context so people get the benefit that they are looking for. He said, we don't want to disrupt them without them getting the payoff that they are looking for. Yes. The researcher referred to this individual approach or as precision behavioral medicine. This is one of the first studies that was able to leverage data collected from each individual and zoom in on his on her personal response, Lewis said. Nice. One of the main example of how the researcher personalized the message was by considering the weather in the area of the user, noticing that certain messages were more effective for certain individual on rainy days, hot days, and so on. Great initiative. The researcher acknowledged the potential concern people may have about trading privacy for personalization, but said that the automation means that the data can be used and then discarded as opposed to stored, and the location setting only needed to commercialize users would able to adjust their setting to select how much information to share, and they plan on conducting more research before applying their approach to a larger populations, right? We are establishing here in there a new tool there is a new tool to use with an established problem. Conrad said, our next project will focus on establishing efficiency. Does this work better than sending message at random or not sending message at all? But once we establish efficiency efficiency, I would imagine that it did be very attractive to device manufacturer to consider this kind of approach. Yes. Other author of the paper include Sarah Hujantina, a former electrical engineering graduate student currently at Advanced Safety and User Experience Sahara Hojantina, an electrical engineering graduate student, and Debro Brunk Resi, research project manager for the Motivation Lab in the College of Health and Human Development. Sure. So basically, it's kind of approach in which they are ready to um, in kind of approach in which the person is able to uh, this company is able to, or the manufacturing company is able to provide messages at the right time, at the right point, through which the person gets motivated to the fitness, which is a great initiative, I think. So yes, now we have our next topic, which is engineers 3D printed personalized wireless wearable that never need a charge. Yes, it's true now, and you will see. This is basically, this article is like a custom custom customizable of every body point. It's first it takes your whole body hologram, or a 3D body hologram, 3D person of your body. Then it can be designed on your body structure, uh, around like our biceps or triceps, like that, and it's like a band, I mean. And you don't want yeah, neither you want a charge thing like in our fitness trackers right now. So it will be a great thing, I think. And it will not provide only the like uh, it will not provide your only the heart rate or a bit rate. It will it will provide everything, uh, in every aspect, that where your body part, or where you have a problem in your body muscles, or in your body. So it will be very beneficial for our doctors also. So it can it like a regular checkup, basically, in your biceps or in your hand, wherever you like to wear it. So yes, this is all about it, and we will also like you will also like to see the a video about this. And it is published on it is on YouTube. So let's think, let see. Variable sensor to monitor everything from step count to heart rate are nearly ubiquitous, but for scenarios such as measuring the onset of fertility in older adults, prominently diagnosing deadly diseases, testing the efficiency of new drugs, or tracking the performance of professional athletes, medical grade devices are needed. Like I said, University of Arizona engineers have developed a type of wearable they call a biosymbiotic device, which has several unprecedented benefits. Not only are the devices custom 3D printed based on a body scan of viewers, but they can operate continuously using a combination of wireless power transfer and compact energy storage. The team, led by Philip Guthroff, assistant professor of biomedical engineering, and Craig M. Berg, faculty fellow in the College of Engineering, published its finding today in the journal Science Advances. Well, it is published on 8th October, so don't please get me wrong. Okay. There's nothing like this out there, said Gutroff, a member of University BIOF Institute. We introduce a completely new concept of tailoring a device directly to a person and using wireless power casting to allow the device to operate 24 into 7 without ever needing to charge. Yes, it is. Custom fit enable precise monitoring. Current variable sensor face various limitations. Smartphones, for example, need to be charged, like I said, and they can only gather limited amounts of data due to their placement on the wrist. But using 3D scan of viewer body, which can be gathered via method including MRI or CT scan, and even carefully combined smartphone images, Gurthrup and his team can 3D print custom fitted devices that wrap around various body parts. Think a virtual, unnoticeable, lightweight, breathable mesh cuff designed specially for your bicep, calf, or torso. The ability to specialize sensor placement allows researchers to measure psychologically parameters they otherwise couldn't. If you want something close to core body temperature continuously, for example, you don't want to place the sensor in the armpit, or if you want to measure the way your bicep deform during exercise, we can place a sensor in the device that can accomplish that, said Tucker Stewart, a doctoral student in the biomedical engineering and the first author of the on the paper. Because of the way we fabricate the device and attach to it to the body, we are able to use it gather data a traditional wrist mounted variable device wouldn't be able to collect. Because these biosymbiotic devices are custom fitted to the viewer, they are highly sensitive, Guthrup said. Tested the device ability to monitor parameters including temperature and strain while a person jumped, of course, walked on a treadmill, and used a rowing machine. In the rowing machine test, subjects were wore multiple devices tracking exercise intensity and the way muscle deformed with a fine detail. The devices were accurate enough to detect body temperature changes induced by walking up a single flight of stairs. Amazing. Continuously wireless and effortless. Guthroff and his team are not the first to adapt variable to track health and body function. However, current variables do not have the ability to track metrics continuously or with enough precision to make medically meaningful conclusions. Some variables used by researchers are patches that stick to the skin, but they come off when skin goes through its normal shedding process or something when a subject sweats, of course. Even highly sophisticated variables used in clinical settings such as ECG monitors face these issues. Also, they aren't wireless, which severely limit mobility. Patients can't go about their normal daily routines if they are tethered to bulky external devices. Yes, it is. The biosymbiotic devices that Guthrup's team has introduced uses no adhesive, and it receives its power from a wireless system with a range of several meters. The device also includes a small energy storage unit so that it will function even if the viewer goes out at the system range, including out of the house. These devices are designed to require no interaction with viewer, Guthrup said. It's as simple as putting the device on. Then you forget about it and it does its job. Like we like we like we wear a watch. That's it. This research was funded by Flynn Foundation Translation Bioscience Seed Grants Pilots Program. The team also been working with Tech Launch Arizona, the commercialization arm of the university, to protect the intellectual property and launch a startup to bring the technology to market. I hope this technology will come to the market. It will with the boom. I think it will going to be boom for many fitness trainer or fitness freaks. So, our next topic is how flawed diamonds lead to flawless quantum networks. Well, we have talked about quantum networks, quantum physics, quantum theory, and something, uh, all these things, or quantum computers. Well, I think quantum networks is very necessary for our upcoming generations, and it will be the essentials basically. So let's see what's now in quantum networks. We have also have an article in our previous stream, or a in our yes in our previous stream, in which I have read about quantum networks and how it will going to change our internet thing. Now we have the same kind of thing, but with high pressure, high temperature. So let's get into this. Let's see what's we have in this article. Lead based vacancy centers in diamonds that form after high pressure and high temperature treatment are ideal for quantum networks, find scientists. The modified crystal system could also find application in spectronics and quantum sensors. Right. The color in a diamond comes from a defect or vacancy which where there is a missing carbon atom in the crystal lattice. Vacancies have been long been able of interest to electronic researchers because they can be used as quantum nodes or point that make up quantum network for the transfer of data. One of the ways of introducing a defect into a diamond is by implementing it with other elements like nitrogen, silicon, or tin. Yes. In a recent study published in ACS Photonics, scientists from Japan demonstrate that lead vacancy centers in diamond have the right property to function as quantum nodes. The use of heavy group of 4 atom like lead is a simple strategy to realize superior spin properties at increased temperature, but previous studies have not been consistent in determining the optical properties of lead vacancy centers accurately, says Associate Professor Takuyuki Iwasaki of Tokyo Institute of Technology, Tokyo Tech, who led the study. Okay. The three critical properties researchers look for in a potential quantum nodes are symmetry, spin, coherence, time, and zeros phonon lines ZPL, or electronic transition lines that do not affect phonons. The quanta of crystal lattice vibration symmetry provide insight into how to control spin. Coherence refers to an intel identicalness in the wave nature of the two particle, and ZPL describe the optical quality of the crystal. The researcher fabricated the lead vacancy in diamond and then subjected the crystal to high pressure and high temperature. Then they studied the lead vacancies using photoluminescence spectroscopy, a technique that allows you to read optical properties and to estimate the spin properties. They found that the lead vacancy had a type of dihedral symmetry which is appropriate for the construction of quantum networks. They also found the system showed a large ground state splitting, a property that contributes to the coherence of the system. Finally, they saw that the high pressure, high temperature treatment they inflicted upon the crystals suppressed inhomogeneous distribution of ZPL by recovering the damage done to the crystal lattice during the implementation process. A simple calculation showed that lead vacancies had a long spin coherence time at a high temperature 9K that previous system with silicon and tin vacancies. Nice. The stimulation we represented in our study seem to suggest that the lead vacancy center will likely to be an essential system for creating a quantum light matter interface. One of the key elements in the application of quantum network, concludes on optimistic Dr. Iwasaki. This study paved the way for the future development of large effective diamond waver wafers and thin diffractive diamond films with the reliable properties for quantum network applications. So basically, it is used in the quantum networks, and like I said in the previous time, we have talked about it, and yes, yeah, it will be beneficial for quantum network applications or in the quantum networks uh, systems. Right. Right. Two-dimensional hybrid metal halide device. So, no. So our next topic is two-dimensional hybrid metal halide device allow control to terahertz radiation. It's a very interesting topic, and you will going to love this. And yes, uh, uh, let's get into this, and you will love this technology by hybrid metal on terahertz radiations. So researchers have utilized two-dimensional hybrid metal halides in a device that allowed directional control of terahertz radiation generated by a spintronic scheme. The device has better signal efficiency than conventional terahertz generator and is thinner, lighter, and less expensive to produce. True. Terahertz refers to the part of electromagnetic spectrum that is frequency between 100 gigahertz and 10 terahertz between microwave and optical and technologies have shown promise for application ranging from faster computing and communication to sensitive detection equipment. However, creating reliable terahertz devices have has been challenging due to their size and cost and energy conversion inefficiency. True. Ideally, terahertz devices for the future should be lightweight, low cost, and robust. Of course, otherwise it will not going to be in our market. But that has been difficult to achieve with current materials. Okay, says Daily Sun, assistant professor of physics at North Carolina State University and co-corresponding author of the work. In this work, we found that a 2D hybrid metal halide commonly used in solar cells and diodes in conjunction with spintronics may meet several of these requirements. The 2D hybrid metal halide in a quotient is a popular commercially available synthetic hybrid semiconductor butyl ammonium lead iodine spintronics refer to controlling the spin of an electron rather than just using its charge in order to create energy, right? Sun and colleagues from Argonne National Laboratory, the University of North Carolina, at Capel Hill and Oakland University created a device that layered the 2D hybrid metal halide with a ferromagnetic metal, then excited it with a laser, creating an ultra fast spin current that in turn generated terahertz radiation. The team found that only did the 2D hybrid metal halide device outperform larger, heavier, and more expensive to produce terahertz emitters currently in use. They also find that the 2D hybrid metal halide properties allowed them to control the direction of the terahertz transmissions. Hmm. Traditional terahertz transmitters were based upon ultra-fast photocurrent, Sun says, but spintronic generated emissions produce a wider bandwidth of terahertz frequency, and the direction of the terahertz emission can be controlled by modifying the speed of the laser pulse and the direction of the magnetic field, which is turn affects the interaction of magnons, photons, and spins and allow us directional control. Sun believes that this work could be a first step in exploring 2D hybrid metal halide material generally as potentially useful in other spectronic applications. The 2D hybrid metal halide based device used here is smaller and more economical to produce, is robust and work as well at higher temperatures. Sun says, like we need in our Terahertz devices, right? So this metal will provide this thing. This suggests that 2D hybrid metal halide material may prove superior to the current conventional semiconductor material for terahertz application. Yes, absolutely. Which require sophisticated deposition approaches that are more step susceptible to defects. Okay. We hope that our research will launch a promising test bed for designing a wide variety of low dimensional hybrid metal halide material for future solution based spintronic and spin optoelectronic applications. Hmm. The work appears in Nature Communication and is supported by the National Science Foundation under grant. Postdoctoral researcher Ken Kohn of Argonne National Laboratory, former NC State graduate student Eric Vetter of North Carolina State University, and a postdoctoral research of Lian Wan of UNCCH, and co-first author Hayden Wan, physicist at the Argonne National Laboratory, VU, professor of chemistry at UNCCH, and V. Zhang, associate professor at Oakland University, and are corresponding author of the research. Thank you. So, this hybrid metal or 2D hybrid metal halide will be very beneficial for terahertz devices, and terahertz devices is mainly used between, if you like to say this, um, uh, between in our day-to-day life. I mean, like in a Wi-Fi. Uh, the terahertz devices is the waves are passing through our bodies and like that. So uh, it will be very beneficial because it is very costly, and but through this it will be become easy for our manufacturers and startup companies to get into this. Yeah. You will love this, I think. uh, like I previously said. So so our next topic is our DNA is becoming the world tiniest hard drive. Well, it's like weird maybe sometimes, and sometimes it's weird that our DNA is our DNA is using as a hard drive, but it's not true. Neither we don't wanna do it. Neither I think neither any scientist like this, but it's the fact. So this is the study, and right. So now researchers propose faster method for recording data to DNA, showing promise in the field of digital data storage, neuron recording. In We have shown that through the binary code. I mean, when we are no, around in our 1950s or in 90s era, we are we have a hard disk or a CDs, right? But now we are talking about neuron recording. Can you imagine that? Can you? Because I don't think so, and it's very awkward, to be very honest, but it's a fact. Our DNA stores hell out of things. Hell, or yes, because our body is so complex, right? And uh, uh, in a daily basis, it's evolving, it's changing. due to these circumstances or waves we have around now. So yes, now we are talking about our neuron recording. So are so the para goes like our genetic codes is millions of times more efficient at storing data than assisting solution, right? Which are costly, use immense amount of energy and space. In fact, we could get rid of hard drives and store all the digital data on the planet within a couple hundred pounds of DNA. With a couple hundred pounds of DNA. Can you? Okay, never mind. Using DNA as a high density data storage medium hold the potential to for breakthroughs in biosensing and biorecording technology and next generation digital storage, but researchers haven't been able to overcome inefficiency that would allow the technology to sail. Now, researchers at biosensing and biorecording technology next generation digital, but researchers haven't been able to overcome inefficiency that would allow. Neither I think it going to be on sale. I I think so. Never mind. Now researchers at Northwestern University propose a new method for recording information to DNA that takes minutes rather than hours or days to complete. The team used a novel enzymatic system to synthesize DNA that records rapidly changing environmental signal directly into DNA sequence. A method that the paper's senior author said could change the way scientists study and record neuron inside the brain. Yes. The researcher the research recording temporal signal with minute resolution using enzymatic DNA synthesis was published on September 30 2021 in the Journal of the American Chemical Society. The paper senior author Northwestern Engineering Keith E.J. Toyo says his lab was interested in leveraging DNA natural ability to create a new solution for storing data. The paper's senior author, Northwestern Engineering Professor Keith E.J. Toyo, said his lab was interested in leveraging DNA natural ability to create a new solution for storing data. Nature is a good at copying DNA, right? But we really wanted to able to write DNA from scratch, Tio said. The ex vivo outside the body way to do this involves a slow chemical synthesis. Our method is much cheaper to write information because the enzyme the synthesis the DNA can be directly manipulated. State of the art in intracellular recordings are even slower because they require the mechanical steps of protein expression in response to signal as opposed to our enzyme which are all expressed ahead of time and can continuously store information. Yes. Toya, a professor in chemical and biological engineering in the Mac School of Engineering, is a member center for synthetic biology and studies microbes and their mechanisms for sensing environmental changes and responding to them quickly, bypassing protein expression, expression. Existing method to record intracellular molecular and digital data to DNA rely on multi-part processor that add new data to existing sequence of DNA. To produce a accurate recording, researcher must stimulate and repress an expression of specific protein, which can take over 10 hours to complete. Okay. The TO lab hypothesized the TO lab hypothesized they could use a new method that they called time sensitive untemplated recording using TTT for local environmental signal or turtles to synthesize completely new DNA instead of copying a template of it, making a faster and higher resolution recording. Okay, as the DNA polymerase continues to add bases, data is recorded into genetic code on a scale of minute exchanges in the environmental impact the composition of the DNA it synthesizes. The environmental changes, such as changes in the concentration of metals, are recorded by the polymerase, uh, acting as a molecular ticket tape and indicating the to scientists the time of an environmental change. Using biosensor to record changes into DNA represent a major step in improving turtles' viability for use inside cells, and could give researchers the ability to use recorded DNA to learn about how neurons communicate with each other. Hmm, right. This is really exciting proof of concept for method that could one day let us study the interaction between millions of cells simultaneously. Yes, of course. Said Namita Bhan, a co-first author and a postdoctoral researcher in Toyo Lab. I don't think there is any previously reported direct enzyme modulation recording systems. Yes, from brain cell to polluted water. With more potentially for scalability and accuracy, Turtle could offer the bias for tools that catapult brain research forward, according to Alec Callisto, also a co-first author and graduate student in TeoLab. Researchers can only study a tiny fraction of brain neurons with today's technology, and even then, there are no limits. There are limits on what they know they do. By placing recorders inside all the cell in the brain, scientists could map responses to stimuli with single cell resolution across many million neurons. Yes. If you look at how current technology scales over time, it could be decades before we can even record an entire cockroach brain simultaneously with existing technologies, let alone the 10 of billions of neurons in human brains. Of course, Callisto said, so that something we did really like to accelerate. Outside the body, the turtle system also could be used for a variety of solutions to address the explosive growth in data storage need, up to 175 zettabytes by 2025. Fucking hell. It's particularly good for long term achievable data applications such as storing closed circuit security footage, which the team refers to as data that you write once and read never, but need to have accessible in the event an incident occurs. With technology developed by engineers, hard drives, and disk drives that hold years of beloved camera memories also could be replaced by bits of DNA. Yes. Outside of storage, the ticker tape function could be used as a biosensor to monitor environmental contaminant like the heavy metal concentration in drinking water. While the lab focuses on moving beyond a proof of concept in both digital and cellular recording, the team expressed hope that more engineers could would take interest in the concept and be able to use it to record signal important to their research. We are still building out the genomic infrastructure and cellular techniques we need for robust intercellular recording, Teo said. So, this is the all about recording data or recording neurons. Um, to store data in our neurons or in our DNA. And this is uh, all the university are there who are participating in this, and the researcher from this university have taken up this research. And I'm not going to read this. Well, well, it's kinda like interesting, but I think uh, if it's not human body cells, I mean, like we said, there now we have a 3D printed technology in which you will also make heart or liver or body part like that. So if it's from from that atmosphere, it is built in a 3D printed, then it will be good. But for this reason, if someone like I think you get my point, that don't try it on a person directly. Yes, of course, neither one of the researchers have done that, but there are some crazy scientists in our history, so be careful by that. And yes, it will be a great thing, because as of course we have a hell lot of things like hard drives and um, pen drives and like that, but it will be the mind blowing thing. I said so. That's it from my side. Now we are uh, going to our next topic, which is world smallest brain inspired computer, so small that it can harvest its energy itself. Nice, 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 nice. So let's get into this and see what he's talking about. Well, yeah. The energy consumption of the device will be so small that it can harvest its energy itself directly from its surroundings. The project has received funding from the William Experiment Program. Artificial intelligence has seen explosive growth in recent years, but despite major process, the power required to run algorithms continue to increase. In stark contrast to this, the human brain only requires around 20 volt perform more than 10 quadrillions operations. This is 12 order of magnitude better than modern supercomputer technologies. Okay. That's why we are conducting intensive research into developing new hardware that mimics the structure of the human brain with neurons, synapses, and neural networks known as brain inspired computing. Yes. But even though we have managed to drastically reduce the energy consumption of AI algorithm, there are still long way to go before BIC are as efficient as the human brain when it comes to size and energy efficiency, says Human Farkhani, uh, an assistant professor of the Department of Electrical and Computer Engineering at Aarhus University. He has just received a grant of DKK 1.9 million from the William Experiment Program for a new project looking into the development of a nano-sized BIC system. Mm. If we succeed, we will have the first BIC system. There is no larger than a grain of dust. Mm. What the really? With energy consumption that is so small that energy can be harvested directly from the surrounding environment. In other words, no power supply will be needed, and this will pave the way for a range of new previously impossible AI applications, says Human Farkhani. Of course, if this happens, then it will going to be the boom in the um, AI technology. The the project goes by the same of spin grain and is one of one out of 51 projects that have just received grant totaling experiment 99 million from the William Experiment Program under the William Foundations. Okay, it's will if I pronounce it wrong, then sorry for that. But it it really is a William or Will Willam. Never mind. The program donates money for bold research experiment and pays tribute to William Kahn Rasmussen, the founder of William Foundation, and his tireless experimental approach to life. The researcher behind the 51 experiment ranged from PhD student to professor and represent a wide range of different nationalities. In addition to Aarhus University, grants have been awarded the Aalborg University, the University of Copenhagen, the University of Denmark, the University of Southern Denmark, and the IT University, Roskilde, Roskilde University, and Jews. Jews. Okay. Hmm, great. Now we have our next topic, which is physics create new technique to control qubits, the building block of quantum computing. Uh, a research team that includes two University of Oregon physicists has outlined new technique for controlling the building blocks of quantum computing, a potential significant step toward making such computer more accurate and useful. Physicist David Alcock and David Winland are founder of the New Organ Ions Laboratory, which was recently set up in the basement of Wilmette Hall. They are among 12 authors of new paper, which is based on an experiment at the National Institute of Standards and Technology in Boulder, Colorado. Both scientists previously worked at the Colorado lab and continue to collaborate on the project after coming to the UO in 2018. The technique described in the journal Nature involved the use of trampled ion quantum bits or qubits in quantum computing and simulations. They could lead to improvements in the operation of quantum computers, which still make too many computations error to be effective tools, the physicist says. The problem with quantum computer is that their logic gates, the tool used to perform basic logic function in computing, are really bad. Alcock said. They fail about 1% of the time. He said you can do about 100 operations, then you get garbage out. Of course. Mainland added the whole field is in a stage now because of error that exists that we can do lengthy calculations on simulations of practical value on our machines. The goal is to get to 10,000 operation without error and then add layer of checks to fix the error as they happen, he said. We want to get to the to that point, Alcock said. Then you can use quantum computer for something useful. Right now they are just toys. Winland said trapped ions are like a bowl of marble that have certain magnetic properties. Physicists can apply forces to the ions with different methods, including laser. All Koch said, but lasers are expensive and complex machines, whereas making logic gates using magnetic forces is cheaper and more practical because they can be generated directly with integrated circuits, he said. Of course. What we did here is show these techniques work as well as anyone has done logic gates before, he said. Google and IBM are among the commercial enterprises that have armies of engineers working on such problems, while academic physicists are trying to show there are better, more basic techniques for solving them. Hmm, right. We have shown you can do it in a technical, simpler way, he said. If physicists and engineers can make quantum computer reliable and able to operate with a large enough capacity, they could simulate other systems, Wineland said. For example, a quantum computer could simulate the action of a molecule used in drug therapy without having to synthesize it in a lab. Could stimulate the action of molecule used in a drug therapy without having to. Wow, great. There are some very practical, useful outcome. Winland said, "We are just scratching the surface. Quantum computing is based on the principle of quantum theory, which explain the behavior of matter on the atomic and subatomic level. A quantum bit, a qubit, is the basic unit of information in quantum computing, just as a bit is the basic unit in conventional computing. Unlike a classic bit, which can be 1 or 0, a qubit can be both 1 and 0 at the same time. Right? That's what cubic qubit means. Quantum computing uh, uh, has been around since about 1995, when a mathematician at the Massachusetts Institute of Technology named Peter Shor came up with an algorithm using quantum logic ideas that could efficiently break large number into a set of simpler equations, a process known as factoring, Weinstein said. Yes, that was important because most modern encryption algorithms derive their security from the inability to factorize larger numbers. Yes. Alcock and Milland joined the UO in 2018. Milland was co-recipient of the Nobel Prize in Physics in 2012 for his work on manipulation and measurement of individual quantum systems. He holds the Philip H. Knight Distinguished Research Chair in the Department of Physics. Alcock is the principal investigator in the New Oregon Ions Laboratory. So, yeah, and for the qubits, if you don't know about the qubits, it's for the simple use, it's a two-way. Like a bit is going to be a one-way, but bits qubits is like a two-way. And if you want a proper definition, or if you want article about that, then comment down in this video, and I will uh, write that article, and you will get to explain everything about quantum computing, or qubits, or bits, and something like that, or classical computing, which is present right now. And this quantum physics, or quantum computers, is evolving day by day. So yes, and now we have our next topic, which is how to make full use of wind energy in a compact city. Well, it's mm, a great thing, and like we have a energy crisis in the Europe, in the Middle East, and in the China, and something like that. So you will love. I think it will be very helpful for those areas, and at least for some people, of course. And then which whatever the city is building, they will like to use this as a thing. And there is also one article in which in the desert area, you can use never mind, it's another topic. We will talk about this later. But this, how to make a full use of wind energy in compact city. Okay, now let's get into this. Wind can be used as a renewable energy source that is clean, uncontaminated, and unexhaustible. Such characteristics have helped wind energy technology to key contributor to sustainable development in a society, which is needed given the ever increasing sizes and population of our cities. These urban settings can certainly benefit from the implementation of wind energy strategies, and has attracted notable attention in recent years. For her PhD research, Yu Hussein Juan investigated how to enhance urban wind energy and potential in a compact city environment. Her research revealed that proper design of high-rise building could give rise to existing new possibility in relation to urban wind energy. One way to limit urban sprawl in our city and to concurrently achieve more sustainable urban development is to employ the concept of the compact city. The compact city refers to the concept of employing good planning to achieve an overall more compact sustainable urban building form or arrangement, not only involving higher densities of high rising building but also linked by an efficient public transport system with increased urban densification, the design and sustainability to compact sizes. Cities with high-rise building has become more important, more turbulence. Building with a height of 100 meter or more uh, are now quite common in many cities around the world. With these buildings subject to high altitude winds, it could be huge waste if we do not exploit such structure for the production of high altitude wind energy as the wind passes through the narrow spaces between high-rise buildings. Faster moving wind speeds can result with the potential to be converted into other form of energy. Yes. However, wind tends to be more turbulent and less predictable in urban area due to complexity and heterogeneous roughness of the terrain. Therefore, high resolution and accurate assessment of the urban wind are crucial towards gathering information that could be used in design of installation to fully exploit wind energy as an effective tool for early stage urban design. Simulations using computational fluid dynamics has been recognized as a key tool for analyzing the potential of urban wind energy. Location, location. For her PhD research, Yu Hussein Juan research explored the potential for urban wind energy generation subject to a number of parameters for high-riser buildings in close proximity such as urban layout, building corner design, and urban density (CFD). Validation results show reasonable agreement for the mean streamwise velocity and turbulence intensity between the CFD prediction and data from wind tunnel experiments. Yu Hussein noted that the spacing between the buildings, which is usually very small compared to the building height for compact high rise building areas, can significantly increase the mean wind speed and the wind energy potential because of the well known concentration effect. Therefore, the impact of building geometry and their arrangement are of particular interest when it comes to characterization and improving the urban wind energy potential. Hussain research has revealed that it can be more effective to investigate wider design alternatives through early urban design planning and thereby devise the optimal configuration of high-rise buildings and in the so-called complexity to realize the feasibility of urban wind energy harvesting for sustainable urban development. So you have read this, and for the high-rise building, it's given a opportunity for harvesting wind energy, and I think it's a great initiative by you Hussein. Right, so now we have our next topic which is researchers create self-aware algorithm to ward off hacking attempts. Now day by day the scientist or researcher and or hacker or a programmer or a developer or whatever human I said who are into this field, software field, is kind of like this, and it will be very beneficial for you, I think, and it will be a great article for you, and to know that how we can easily be protected, and also how these hacking attempts is doing in this world. So yes, let's dive into this, and see. It sounds like a scene from a spy thriller, right? An attacker gets through the IT defense of a nuclear power plant and feels it fake, realistic data, tricking its computer system and person into thinking operational or normal. The attacker then disrupts the function of key plant machinery, causing it to misperform or break down. By the time investing operator realize they have been duped, it's too late with ca- ca- catastrophic results. Of course, the scenario isn't fictional. It happened in 2010 when the Stunet virus was used to damage nuclear centrifuges in Iran, and as ransomware and other cyber attacks around the world increase, system operators worry more about these sophisticated false data injection strikes in the wrong hands. The computer model and the data analysis based on artificial intelligence that ensure smooth operation of today's electric grids, manufacturing facility and power plants could be turned against themselves. Of course, Purdue University Hani Abdel Khalik has come up with a powerful response to make the computer model that run this cyber physical system both self-aware and self-healing. Using the background noise with this system data stream, Abdel Khalik and his student embedded invisible ever-changing one-time use signals that turn passive component into active watchers. Even if an attacker is armed with perfect duplicate of a system model, any attempt to introduce falsified data will be immediately detected and rejected by a system itself, re- requiring no human response. We call it covo- covert cognizance, said Abdul Khalik, an associate professor of nuclear engineering and research at with Purdue Center for Education and Research in Information and Insurance and Security. Imagining having a bunch of bees hovering around you. Once you move a little bit, the whole network of bees responds. So it has the butterfly effect. Here, if someone sticks their finger in the data, the whole system will know that there was an intrusion and it will able to correct the modified data. Hmm. Trust through self-awareness. Abdul Khalik will be the first to say that he is a nuclear engineer, not a computer scientist. But today, critical infrastructure system in energy, water, and manufacturing all use advanced computational technique, including machine learning, predictive analytics, and artificial intelligence. Employees use this model to monitor readings from the machinery and verify that they are within normal ranges. From studying the efficiency of reactor system and how they respond to equipment failures and other disruption, Abdul Khalik grew familiar with the digital twins employed by this facility. Duplicate simulation of data monitoring model that help system operators determine when true error arise. But gradually he became interested in intentionally rather than accidentally failures, particularly what could happen when a malicious attacker has a digital twin of their own to work with. It's not far-fetched situation as the simulator used to control nuclear reactor and other critical infrastructure can be easily acquired. There's also the perennial risk that someone inside a system with access to the control model and its digital twin could attempt a sneak attack. Traditionally, your defense is as good as your knowledge of the model. If they know your model pretty well, then your defense can be breached. Of course, said Yenny Lee, a recent graduate from the group whose PhD research focused on the detection of such attacks using model-based methods. Ab- Abdel Khalik said any type of system right now that is based on control looking at information making a decision is vulnerable to these type of attacks. If you have to access the to the data and then you change the information, then whoever making the decision is going to be basing their decision on fake data. Of course, To thwart this strategy, Abdul Khalik and Arvind Sundaram, a third year graduate student in nuclear engineering, found a way to hide signals in the unobservable noise space of the system. Control model juggle thousands of different data variables, but only a fraction of them are actually used in the code calculation that affect the model output and prediction by slightly altering these non-essential variable. Their algorithm produces a signal so that individual components of a system can verify the authenticity of the data coming in and react accordingly. When you have components that are loosely uh, coupled with each other, the system really isn't aware of the other components or even of itself, Sundaram said. It just responds to its inputs, of course. When you are making it self aware, you build an anomaly detection model within itself. If something is wrong, it needs to not just detect that, but also operate in a way that doesn't respect the malicious input that's come in. For added security, these signals are generated by the random noise of the system hardware. For example, fluctuation in the temperature of power consumption. An attacker holding a digital twin of a facility model could not anticipate or recreate these virtual shifting data signatures, and even someone with internal access would not be able to crack the code. Anytime you develop a security solution, you can trust it, but you will still have to give somebody the keys. Abdul Khalik said, if that person turn on you, then all bets are off. Here we are saying that the added per- perturbation are based on the noise of the system itself. So there's no way I would know what the noise of the system is, even as an insider. It's being recorded automatically and added to the signal. Through the paper published by the team members so far have focused on using the paradigm in nuclear reactors. The researchers see potential for application across industry. Any system that use a control loop and sensor, Sudram said. The same method could be used also for objective beyond cybersecurity such as self-healing anomaly detection that could prevent costly shutdowns and new form of cryptography that would enable the secure sharing of data from critical system with outside researcher, of course. And that's where cryptocurrency or blockchain technologies came in, and it will be amazing, I think. So, yes. Cyber gets physical, of course. As nuclear engineer Abdul Khalik and Sundaram benefit from the expertise and resources of Sirius to find entry point into the world of cybersecurity and computer science. Abdul Khalik credits Elisa Benton, the Smile D. Conte Professor of Computer Science and CRS Research Director, with the o- original spark that lead to creating the convert cognize algorithm. Thanks to the center for exposing him to new partnerships and opportunities. Founded in 1998, CRS is one of the oldest and largest research centers in the world, concentrating on cybersecurity. Its mission, says managing director Joel Rasmus, has always been interdisciplinary, and today the center works with researchers from 18 departments and 8 colleges at Purdue. Abdul Khalik Research is a perfect example of this diverse network. When most people think about cybersecurity, they only think about computer science, Rasmus said. Here's a nuclear engineering faculty member who is doing unbelievable great cyber and cyber physical security work. We have been able to link him with computer scientists at Purdue who understand this problem but yet don't understand anything about nuclear engineering or the power grid, so they are able to collaborate with him. Yes. Abdul Khalik and Sunram have begun to explore the commercial possibility of convert cognizance through a startup company. That startup, Convert Defense LLC, has recently engaged with Entanglement Inc. Entanglement Incorporation, an early stage deep tech company, to develop a go to market strategy. In parallel, the team will working develop a software toolkit that can be integrated with the cyber physical test bed at Sirius and Pacific Northwest National Laboratory, where sensor and actuators compelled to software provides a simulation of large-scale industrial systems. We can provide additional application for the technology that he's developing, since this is an idea that can help nearly every cyber physical domain, such as advanced manufacturing on transportation. Rasmus said, we want to make sure that the research that we are doing actually helps move the world forward, that it helps solve actual real world problems. Nice. Of course. Now we are now this is the second last topic of this stream, and let's see. Well, it's like more like a thing that in this I mean in this topic, we will going to see that how high speed drone can easily detect the locations or in the um, area basis. Of course, drone is the new technology or the upcoming thing in our security. Of course, also in our army, in different army in the world, and it can easily detect or give information to us uh, of terrorist base or a different location, and also see the whole uh, uh, the map of the area through which everyone will be safe for at least for our soldiers. And it is a great initiative, and I think Israel is one of them who is building very fast. And now, but this article is not from Israel, of course, but now we'll get to see that how uh, unknown locations or where mostly humans can't go, uh, can we can easily see the grounds of that plane. And yes, that's all it about it. And now we are reading this article. uh, yes, flying high speed drone with the into the unknown with AI. Like I said, researcher at the University of Zurich had developed a new approach to autonomously fly quadrators through unknown complex environment at high speed using only onboard sensing and computation. The new approach could be useful in emergency on construction site or for security application. Yes. When it comes to exploring complex unknown environments such as forest, building, or caves, drones are hard to beat. They are fast, agile, and small. They can carry sensors and payloads virtually everywhere. However, autonomous drones can hardly find their way through an unknown environment without a map. For the moment, expert human pilots are needed to release the full potential of drones. Yes. To master autonomous agile flight, you need to understand the environment in a split second to fly the drone along collision free path, said David Musa, who leads the robotics and perception group at the University of Zurich. This is very difficult both for humans and for machine. Expert human pilots can reach this level after years of prevalence and training, but machines still struggle. The AI algorithm learns to fly in the real world for simulated export. In his study, Skara Musa and his team has trained autonomous quadrilateral to fly through precisely unseen environments such as forest, building ruins, and trains, keeping speed of up to 40 km and without crashing into trees, walls, or other obstacles. All this was achieved relying only on quadrilateral onboard cameras and computation. The drone neural network learned to fly by watching a sort of simulator expert an algorithm that flew a computer generated drone through a simulated environment full of complex obstacles at all times, and the algorithm had complete information on the state of quadrature and reading from its sensor and could rely on enough time and computational power to always find the best trajectory. Such a simulator expert that could not be able uh, could not be used outside of simulation, but its data were used to teach the neural networks how to predict the best trajectory based only on the data from the sensors. This is a considerable advantage over exciting system which first use sensor data to create a map of the environment and the then plan trajectories within the map, two step that require time and make it impossible to fly at high speeds. No exact replica of the real world needed. After being trained in simulation, the system was tested in the real world where it was able to fly in a variety of environments without collision at the speed of up to 40 km per hour. While humans required years to train, the AI leveraging high performance simulators can reach comparable navigation abilities much faster, basically overnight, says Antonio Locurcio, a PhD student and co-author of the paper. Interestingly, these simulators do not need to exact replica of the real world if using the right approach. Using simplistic simulator are sufficient, adds Ilya Kaufman, another PhD student and co-author. The applications are not limited to quadrat. The researcher explained that the same approach could be useful for improving the performance of autonomous cars or could even open the door to a new way of training AI systems for operation in domains where collecting data is difficult or impossible, for example, on other planets. Of course. According to the research, the next step will be able to make the drone improve from experiments experience as well as to develop faster sensor that can provide more information about the environment in a smaller amount of time, thus allowing drones to fly safely even at speed of above 40 km per hour. Great. Nice, nice, nice. So, this is our last topic or last article which we're going to discuss it. And after this podcast will be over. And okay, let's get into this. Low cost portable device could diagnose the heart attacks in minutes. Researchers from the University of Notre Dame and the University of Florida have developed a sensor that could diagnose a heart attack in less than 30 minutes, according to a study published in a lab on a chip. Currently, it takes healthcare professionals hours to diagnose a heart attack. Initial result from an echocardiogram can quickly show indication of heart disease, but to confirm a patient is having a heart attack, a blood sample and analysis is required. Those results can take up to 8 hours in a traditional way, of course. But through this device, it can take up to around 30 minutes. The current method used to diagnose a heart attack are not only time intensive, but they can also have the applied within certain window of time to get accurate results, said Pioneer Zolinter, the Xian family collegiate professor of engineering at the Notre Dame and lead author of the paper. Because our sensor targets a combination of miRNA, it can quickly diagnose more than just heart attacks without the timeline limitation. But by targeting three distinct types of microRNA, miRNA, the newly developed sensors can distinguish between an acute heart attack and reperfusion, the restoration of blood flow, or reperfusion injury, and requires less blood than traditional diagnostic method to do so. The ability to differentiate between someone with inadequate blood supply to an organ and someone with an reperfusion injury in an unmet clinical need that this sensor addresses. The technology developed for this sensor showcases the advantage of using miRNA compared to protein based biomarkers. The traditional diagnostic target, said Hsu Chia Chang, the Baird Professor of Chemical Biomolecular Engineering at Notre Dame and co-author of the paper. Additionally, the portability and the cost efficiency of this device demonstrate the potential of it to improve how heart attack and related issues are diagnosed in a clinical system settings and in developing countries. A patent application has been filed for the sensor, and the researchers are working with Notre Dame Idea Center to potentially establish a startup company that could manufacture the device. Bioengineer Chang and Sorrent are both affiliated with Notre Dame Institute of Precision Health. Additional co-author from Notre Dame are Stuart Renblad, Cameron D. Shelter, Bradley Ellis Jan Rang, George Ronan, and Satya Jyoti Senapati. Co-author from the University of Florida are David Anderson, Alien Handberg, Keith March, and Carl Pepline. The study was funded by the National Institute of Health, National Heart, Lung, and Blood Institute in America. So that's all about it for today, and uh, I would like to talk for sometimes uh, for a little bit. Like I said, Post Scientist is a website, is a blog website which going to upload this article, but it's under processing, and it's under construction, of course. But after due to which we are not able to put articles right now. But after the website is going to be live, uh, the links will be provided in the description. And yes, uh, also follow our socials, or especially Twitter, because we are mostly live on Twitter, and through which you will easily contact with us. And uh, if you have any idea or anything like that, then please contact me, or in this any in any platform basically. And yes, this is all about it. And and also I would like to tell you that okay, never mind, just leave it. um now uh, now we just end this podcast, and get see you tomorrow, in the see you tomorrow by almost this time only. And okay, thank you.